Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to our first video in the ECG series, and the topic for today is ECG basics. Now, one of the first things that you need to master if you want to become an expert in interpreting an ECG is wave recognition. Right? So basically, you have a few basic waves in every ECG, right? The first wave is the P wave, right? And then you have isoelectric line after that known as the PR segment. And then you have another wave known as the Qrs complex, and then you have a T wave. So these are the three basic waves of an ECG. Now the P wave basically corresponds to atrial activity, right? So if you look at the heart, what happens is that the electrical activity in the heart starts from the SA node, and from here the electrical activity goes down towards the AV node, and it goes towards the left atrium as well, right? So this is how the atrial activity is actually spreading from the SA node towards the whole left and right atrium, right? And this atrial activity, what it causes is it causes this P wave in the ECG, right? Then afterward, this what happens is that this place over here is known as the AV node. This was the SA node, this is the AV node. Now an AV node is actually one of the structures which is actually the only conduction place between the atria and the ventricle. So the electrical activity cannot go from the atria directly into the ventricle. It has to go through the AV node. Right now, the property of the AV node is that once the AV node receives an impulse, it doesn't just conduct the impulse rapidly. It actually takes some time, and after a while it actually conducts the impulse down into the ventricles, right? And this time that that the AV node actually takes is actually represented by the PR interval from the start of the P to the R of the QRS, right? This is known as the PR interval. So this basically corresponds to the AV node, and the AV node basically taking its time to release the impulse downwards. So once the impulse actually goes downwards, what happens is that the ventricles now start to depolarize, right? And when the ventricles depolarize, what happens is that we see a wave which looks somewhat like this, right? This is known as the Qrs complex, and you can actually see that this is more high amplitude, and the frequency, the spikiness of this wave is greater as compared to the P wave. So this actually denotes that there is actually a faster kind of an electrical activity going on in the heart. It's a quick, fast electrical activity, which is represented by the Qrs complex, right? So once the ventricles they depolarize, what happens next is that there is now a phase of repolarization, right? And the ventricle repolarization is represented by the T wave, right? So you have three basic forms. You have a P wave, you have the Qrs complex, and then you have the T wave. Now the science of wave recognition is very important, and the reason is that this is like a ideal ECG. You have a P wave, and then you have a QRS complex, and then you have a T wave, right? But you don't actually see this all the time, and many times what happens is that the P wave could be on top of the T wave, right? Or they could be very close together, and you might not able to differentiate whether this is a T wave or this is a P wave, or this is some sort of an abnormal T wave. So sometimes it can get very, very confusing and very difficult to actually differentiate between these at least these two waves. And therefore the wave morphology becomes very important, right? So the way we differentiate the three waves is by understanding the frequency, right? So the QRS complex has the highest amplitude and frequency. It's the most spiky, pointed of all the three, right? Now this is still fairly simple to identify QRS complex, right? And then the T wave is the smoothest out of the three. The T wave is the smoothest, so it's somewhat like this, right? And the P wave is actually somewhere in between, right? So it's not as smooth as the T wave, and it's not as pointed as the QRS complex. So it's somewhat like this, right? So in an ECG, what we actually try to do is we compare. We compare. If you have to compare, if you have to find which is the P and which is the T, then we have to see that which is actually higher in its frequency, and which is actually lower in its frequency. So the one which is more pointed, is most likely the P wave, and the one which is more smooth and covers a larger area is the T wave. So the reason why it's important to know the P, QRS and the T is because we want to differentiate between normal and abnormal, right? So in this ECG we have a P, QRS, T, then we have another P, then we have a QRS, then we have a T, and then we have no P's, right? And we have something which is like this. Is this a P? Right? So now the thing is, now we need to compare. So our P was somewhat like this, RP was somewhat like this. So this is not what a P actually looks like. So this most likely looks like a premature atrial beat, right? And what is a premature atrial beat? Basically, you have, your normal conduction starts with the SA node, right? The SA node, electrical activity goes to the AV node, and then into the bundle of His and into the ventricles, right? But sometimes what can happen is that you might have a ectopic area in the heart which actually is starting to produce its own electrical activity, right? And when it produces its own electrical activity, what can actually happen is that this might produce a abnormal looking P wave, right? You can see that this P wave is actually upside down, which means that it is not actually coming from the SA node, it's coming from somewhere else, and because it's coming from somewhere else, it's abnormal looking, right? And again, my point here is that you need to compare. You saw the P wave over here, you saw the P wave over here, here you see something different, and that's why you can actually say that no, this is not coming from the SA node, it's coming from somewhere else, perhaps somewhere in the right atrium. So in the ECG, it's a must to compare waves. Right now, the comparison should not just be on morphology, but it should also be on the duration, right? On the regularity. Now, usually what happens is that the QRS and the QRS complexes, they are spaced at a regular interval, right? And the P waves are actually spaced at a regular interval. So the RR interval, which we say, which is from one R to the other R, is actually a constant through the whole ECG of a normal person, right? And so is the P interval, right? So you have the P wave and the P wave over here. The interval between the two is also constant in most cases. So this is also something you have to look for, right? Right, so if this is the PP interval from here to here, and then you have another PP interval from here to here, these two PP intervals are actually constant in a normal ECG. So now what we expect is that the same duration from here to here, we expect the next P to also be in the same duration. The same duration should be also here, right? And what we see over here is that we don't see a P occurring over here, but we see an inverted kind of a P wave actually occurring early, right? And that actually gives us a hint that this is something else. Maybe it's not occurring from the SA node, it's occurring from an ectopic foci. So the purpose of giving this example was that the comparison is actually made on two things, right? The comparison is made on the morphology of the wave, right? Here we saw that the morphology of the P wave was not what it normally looks like as we could see over here. The other thing is that the comparison is based on the regularity, you know. Now these P waves were occurring at a regular fashion, but here you saw something which was not quite regular. You saw that this was actually occurring way before time. Now in order to do a quick comparison, when you are faced with a real ECG and you actually want to see whether the P waves are occurring on time, you should have your tools. And what are the tools that you require for good interpretation of an ECG? Yeah, the first thing is that you might require a pair of calipers. Now, what are calipers? I don't have a caliper right now. This is basically a compass, but you can just imagine that a caliper has these two of these pointed things. I'm sure you would have seen it. And so basically, if you have this, it becomes very easy actually to find the regularity, because you can just put your calipers here and find the pp interval, and then find put your caliper again and find the other pp interval, and then when you put your caliper here, you can actually just tell that what, this is occurring much more earlier. So a caliper is something which a person, if you're interpreting an ECG, you must have a caliper, so you can very quickly see the the regularity. Now the other tools that you should carry with yourself, apart from the calipers, are a pair of you should carry a ruler, a pencil, and a calculator. So make sure that whenever you're actually interpreting ECGs, you have your tools with yourself. Now this comparison which is actually made on morphology, regularity. So when you look at an ECG, what you have is that you have a tracing of one lead, and then below that you have a tracing of another lead, and then you have another the tracing of another lead before that, beneath that. So there's a comparison which we make within one lead, and then there's a comparison which we make while comparing different leads. Okay, I'll give you an example. Now imagine that this is one lead. For example, this is lead 1, and beneath lead 1 we have another lead known as lead 2. Right now you can actually see in this waveform that you can actually see this thing. Right now some people might be confused whether this is a P wave because it looks very small. Right, so to answer this question whether this is a P wave or this is something else, what we can do is we can do a comparison. What do I mean by a comparison? Right now in this lead, you can see a very good looking a P wave, right? And in order to know whether this is a P wave, all you need to do is you just need to go down and see whether it's actually matching this. Right now this P wave is actually occurring, this bump is actually occurring at the time when the P wave was occurring, then this in fact is the P wave. Right now different leads will show these waves in a different way. Right, some may show P waves in a very good way, some might not show these P waves in a very good way. Right, similarly if you look at this P wave and you go down, you would actually see that this wave is actually corresponding this wave. So this in fact is a P wave, and so this is also a P wave. Now why this is actually helpful is that in many situations you have P wave which is sitting on top of a T wave, or you have P waves sort of mixed with the T wave, and there it's very difficult to sort of say whether this is an abnormal looking T wave, or whether this is a T wave and a P wave together side by side. So in order to differentiate that, we can use this comparison, comparing the different leads. In one lead you can see a very well defined P wave, and then you can just go down and just compare whether the other lead that you were seeing whether that segment is matching with the well defined P wave that you saw in the other lead. Now the other thing that you need to understand is that you also need to know that certain waves are best represented in certain leads. For example, you have the P wave which is best seen in lead 2 and V1. Right, so you have lead 2 and V1 which actually show you the best kind of P waves. So if you are actually looking at an ECG and you're looking for P waves, or you're looking for abnormalities in P waves, and you're not looking in the right leads, that can cause a misdiagnosis. Right, so you have to look at the right leads. Waves are best seen in the inferior leads and V1. Right, V1, 2, 3, AVF. These are the inferior leads, 2, 3, AVF and V1. Right, if you don't know these leads, it doesn't really matter. Just remember that there are certain leads which actually show these waves in a better way. And so when you're looking for a certain type of wave, abnormality in certain type of wave, you actually should actually start with the more important leads, where you can actually find these waves. Now we discussed about comparison. Right, comparison is very important if you want to recognize a wave. Wave recognition, you need to compare the waves. You need to compare the waves in one lead, and you need to compare the leads between different leads. right? And you need to look for regularity, whether you have an early wave occurring, whether it's occurring on time or not, right? So this is something, comparison is very, very critical. But there's another thing, and that is pattern pathophysiology. What that means is that you should know about, you should just not know patterns, but you should know the reason why these patterns are occurring. For example, in this case we discussed that this is actually a premature atrial beat, right? What's happened here is that the right atria has this abnormal area of electrical activity, and what that abnormal area does is that it sort of fires before the EV node, before the SA node can actually fire. And so what happens is that we have a beat that is looking abnormal, and it's actually occurring early because there is this ectopic area which is actually fired before the SA node, and so you have this early beat. Now, how do you actually confirm whether this is an early beat? The other way we can actually confirm is that we should know about the pattern pathophysiology. We should know that if you have an early beat, what happens next, right? So the early beat, like all other beats, will actually go into the AV node, and then from the AV node they will go down to the ventricles, right? But if you have an early beat, what happens with the AV node is that the AV node does not it does not respond as it does for a normal beat occurring on time. So if you give an AV node an early beat, what it will do is that it will take more time to respond to it. So normally we know that the AV node has this delay. It doesn't just conduct. It has this slight delay, which is measured by the PR interval, right? But if you give the AV node a beat which is early, it actually increases the delay. This is how the AV node works. This is the pathophysiology of the AV node, and this is what I mean by pathophysiology. So what happens is, if you have an early beat, this interval, this interval which you could actually see over here, this becomes bigger, and this is one clue that this is actually an APC, right? So this is what I mean by pattern pathophysiology. The other thing that happens is that once this this ectopic beat actually it fires, what it also does is it resets the SA node, right? So it actually it further slows the AV node, and it also, what it does is it resets the SA node. So what happens as a result of this is that after the T wave, what happens is that the next wave actually takes more time to occur, right? And this is known as the pause. Right? So there's this pause, there's this sinus pause that actually occurs. So this sinus pause, it occurs because this ectopic beat, when it fires, it it causes the SA node to just think that there is some other pacemaker in the heart. There's some other area which is actually going to now take over the SA node. And so once this ectopic beat goes away, the SA node is still taking its time to get back, to get back into its normal working state, and that's why you have this pause, right? So this is what I mean by pattern pathophysiology, right? We knew about this wave looking abnormal in its morphology, occurring early, and then we saw this this delay, this prolonged interval, PR interval, and then what happened was that we had this sinus pause. So all these criterias are actually meeting the criteria of a premature beat, or a PAC, premature atrial contraction. Now, although this is actually a basic level lecture, and perhaps PACs is not that basic a topic, but my point here is that you should know certain things about the AV node, certain things about the SA node, certain things about the the pathophysiology, so you can actually predict what happens. An early beat, atrial beat, will cause the AV node to cause it to delay even further, right? And these ectopic beats, what they do is they reset the SA node, and so you have these pauses occurring. Now if you want to know about the limb leads, imagine that you have a pizza in front of you, right? And a pizza usually has 8 slices. We're going to rub these two lines, this line and this line, right? And the lines that are left are limb leads, right? So easy mnemonic to learn these limb leads is